Now, I know that you guys know how to take care of problems like this. Seriously? Seriously. Why? Yeah, I told you not to say anything, so huffing is better.
That's bad. I didn't do that.
We're going to be 10 and 10.
10 and 10? Are you even kidding me? Are you kidding me? We're trying to add fractions. What must we have? Common denominators. You don't just add straight across, because if that is the case that you just add, if it's the case that you can just add straight across, let me show this to you. So you say that if I have 1/2 plus 1/2, no, you don't. I'm going to get 2 over 4. Oh, I better reduce that, because you know Mr. Craig hates it when I don't reduce. See, that's bad. So bad. My brain it hurts. The pain, suffering.
The common denominator is 12.
Common denominator is crazy. See, now I've got to redo my whole problem. You said the common denominator is 12 because you just know it, right? Because you're so awesome. And what you're really doing is this. 6 is 2 times 3, right? You all agree?
Mm-hmm.
4 is 2 times 2. When you get a common denominator, you're finding a common multiple. You're finding something that has the exact same factors for both of these. So when we do this, is there a factor missing from this guy that the other one has?
2.
This guy has 2 2's, he only has 1, right?
Mm-hmm.
So I put a factor of 2 here, but I also have to put that in the numerator, otherwise I've changed my problem. So this is 2 over 2, that's legit. Okay? Here, is 4 missing a factor that he sees over here?
Mm-hmm.
He's missing a factor of 3. Now you guys could probably say, well, Mr. Craig, I knew that the common denominator is going to be 12. Why do I have to go through all that? Well, sometimes finding common denominators is not this easy. What's 2 times 3 times 2? 12. What's 2 times 2 times 3?
12.
It's still 12. Now your numerator is this when you multiply it. So you get 14 plus 9. So what's my answer?
23.
23 over 12. You guys with me on that?
Just not the traditional way I'm used to working.
It's not, but that's how it's best to do that. If you can see the factors, you can see what the numbers are made up of, then it makes the next stuff easier. Because these guys don't have like denominators. But if I look at it based on its factors, then when I come to things that deal more with polynomials, it's not that big of a jump to make the connection here. So if I have 3 over x squared plus 7x plus 10 plus 4 over x squared plus 5x plus 6. Do these guys have the same denominators? No. And trying to get an LCD for this is going to be crazy. Unless I view these guys using their factors. What are the factors for this first denominator?
X plus 5, x plus 2.
X plus 5, x plus 2, bless you.
Thank you.
What about x squared plus 5x plus 6?
One and 6.
X plus 2 and x plus 3. Now I'm going to ask you the same question that I asked you above. What factor is missing from here that he sees in the other denominator?
Plus 3.
He doesn't have an x plus 3, does he? But I have to put that in the numerator as well, otherwise I've changed the problem.
And x
This guy's missing the factor of x plus 5, right?
Mm-hmm.
Now, does everybody have the same denominator?
Mm-hmm.
So my denominator is comprised of the same three factors. Now, it doesn't matter what order the factors are in.
Mm-hmm.
Why does the order not matter here?
Because it's multiplication.
Because it's multiplication. That's the beauty part about this. It's multiplication, so the order of the factors doesn't matter. Now you just need to worry about what does the numerator become. Because I changed the numerator from a 3 to 3 times x plus 3. So what does that become? That's 3x plus 9. And when I distribute the other part, that's 4x plus 20. Do y'all agree?
Yes.
7x.
Okay.
29
So 7x plus 29 when I combine those like terms. And that's all over these three factors.
See if I can ask these right.
Well, before you ask the question, let me just point out here that 7x plus 29 doesn't have a common factor. There's no way to factor that top. So you've done all that you can with this problem. Some problems, after you go through the process of combining them, there might be more factoring to do. Okay. Yes, what's your question?
Okay. When you did the, you factored out x squared plus 7x plus 10.
Right.
So that's basically.
Factored as x plus 5, x plus 2.
5 plus 2. And you factored out x squared plus 5x plus 6.
All right, this factors as x plus 2, x plus 3.
Okay. But still wasn't 8.
They're not the same, right?
Right.
Now, just like above here, 2 times 3 is not the same as 2 times 2, right?
So you kind of have to borrow from, not borrowing.
It's not borrowing, it's you're putting in the missing factor so that everybody has the same thing. So like, I've got 2 kids, right? If I were to buy the first kid x plus 5 and x plus 2, and buy the other kid x plus 2, x plus 3, this kid's gonna be mad. It's like, why does he get an x plus 3 and I don't get one?
Because it equals the same.
Okay, so fine, I'll give you an x plus 3. Are you happy? If I give this guy an x plus 3, he's happy, right?
And then the other one's gonna get.
The other one's gonna get ticked off. Like, how come he's got an x plus 5? I want to have. Everybody has to have the same, right?
Except when you have a daughter. When it was a boy and a girl.
No, it's a boy and a girl. She's gonna be a tomboy. That's just the way it is. She will play with Legos and Hot Wheels, and she'll love football. But I don't have to worry about it. I've got boys.
I understand.
I've been blessed.
Nothing wrong with girls.
No, my wife's a girl.
Exactly, so there's nothing wrong with girls.
No, I've got one girl in the house. That's it. I'm good. Now, so you put in the missing thing so that all these guys have to be exactly the same. The order doesn't matter because it's multiplication, right? But every kid has to have the same thing. Otherwise, there's yelling and screaming and clashing and things don't work out. And then the grader, the daddy, gets mad and starts Xing out everything. Fine, you know what? You got to yell, you get nothing. And that's how great.
So
Okay,
we're gonna get to the
so,
bottom ones. I'm
yeah.
sorry.
No, so when you get down here, everybody has the same denominator, right? So that's my common denominator right here. And I distribute to get the 3x plus 9. And I distribute this guy to get the 4x plus 20. And then I combine those, what's in the numerator.
So what you add on the bottom, you're going to have to multiply on the top.
Right, because x plus 3 over x plus 3 is equal to what?
1.
So I'm multiplying times 1, which doesn't change it. It makes it look different, but it gives me something that is equivalent. Remember that? You made equivalent fractions like up here. Really what's going on is that I'm rewriting this to say 14 over 12 plus 9, plus 9 over 12. 9 over 12 is the same as 3/4, right? This is an equivalent fraction. 7 over 6 and 14 over 12 are the same number. They just look different, right? And I had to make them look different. Had to make equivalent fractions so now the denominator was the same. That's what you did with fractions. You got something that looked different, but it had the same meaning. Right? It looks different, but it has the same meaning.